Good afternoon, dear students. Welcome to Data Structures and Algorithms class. Today, we are going to talk about arrays, strings, and of course, two-dimensional arrays with example programs. First of all, let us understand what is an array. An array is a collection of similar data items. So, all the data items that you store are referred to a common name or a single name, and they are all of same data type. So whenever you want to have 10 numbers, so instead of giving 10 variable names, what you can do, you can give you can create an array, and on a single array name you can store all 10 numbers. So that is possible. And of course, one-dimensional array is just like a list. Two-dimensional array is just like a table where you have rows and columns. And in C language, what happens? C language supports the creation of array up to the capacity of your computer memory. There is no limitation. And of course, C array in C, the arrays, one-dimensional array are also called as vectors, and two-dimensional array are also called as matrices. So that is one important thing you should understand. And here is one example how to create an array. So integer I, j, they are all the normal integers, whereas int array, it is the name. It is a name that we have given to create one sample array. So this array can hold 10 numbers. The size, you write it within square brackets. You can write it within square brackets. So it can support 10 numbers. Similarly, this is 1000. It can support 1000. This is a two-dimensional array. Table array is a two-dimensional array where 3 rows are there and 5 columns you have. So that is a thing. Or you can certainly create like this. N number of rows is 100, number of columns is 200. Two integer constants you can create, and of course you can certainly write it like this. So this is also a way in which you can create array. So that is a thing that you should understand. Now, further, how memory is allocated for this array. Normally, whenever we declare an array, what happens? The first element of the array gets the memory address, which you call it as base address of the array. And from that memory address onwards, suppose you have specified 5 elements, what happens? The next 5 elements will get the memory address. For example, look at here. I can help you to draw. This is the base address of the first element. So next element will also get the adjacent memory location. So the next also will get memory adjacent location like this. So similarly, next memory. So it is. And remember, the first element gets identified using an index number called 0. This is the identification for first element, and this is the identification for 2. This is third element, and of course you can see each element gets index numbers. They are identified by index number. So remember one thing, if the entire array is called by name, for example, ARR, so you can certainly refer ARR of 0 means the first cell. ARR of 1 is nothing but the second cell. ARR of 2 means the third cell. ARR of 3 is just like this. You can refer. So, and remember one thing, the first cell address, you call it as the base address, is called the base address. And of course, the number of element and total size of array depends upon what type of data type that you are using. If you are using a character type, of course, it's 1 multiplied by number of elements. If it is integer 4, if it is float, it is 8 multiplied by number of elements. And of course, the memory allocation to the array are successive. So initially you have base memory address for the first element, and next elements gets the successive memory address allocated next to the base address. So this process of allocating the memory goes on till the number of elements that you have in the array. Of course, next we'll discuss what are the types of address arrays. So we can, of course, we have understood already. We can identify each element in the array using subscript number or index number. Index number that starts from 0, 1, 2, 3, etc. I told for each cell the same way. That is the same index number. It is also some textbooks, they are also called as subscript. And there are 3 types of arrays you have: one-dimensional array, two-dimensional array, and multi-dimensional array. Let us discuss each one of them. And remember, arrays comes under the category of derived data type. They comes under the category of derived data type. So that is one thing that you should understand. And further, one-dimensional array. Let us look into one-dimensional array. So in one-dimension array, what happens? Look at here, the first element gets the memory allocation and successively. In one-dimensional array, what happens? There will be series of only one dimension. One dimension in the sense, it's a continuous memory allocation for n elements. Suppose if you have an array of size n, so n elements, what happens? This is the base address, 1000 is the base address, and these elements are of the integer type, which can hold 4 bytes. So what happens? The next array element will get 1004, next will get 1008, next 1012, similarly up to n. So n minus 1. So all the elements, since we have started the index by 0, so we'll end by n minus 1. This is how we can get it. And in many of the placement interviews, they ask, if they give the size of the array, here the size is around 10, just imagine, and each integer array occupies 4 bytes. So what is the total size? So in such cases, you can certainly say 4 into number of elements. So it is 40 bytes. So it is just like that. You will get some questions. So the total memory allocated for an integer array of n elements is equal to number of elements into the size of each element. So here n is the size and size of the array, and 4 bytes are the bytes that are occupied by each element. So n into 4, so it is 40 bytes. So 40 bytes you can certainly take, and if it is 500 elements, 500 into 4, so it is 2000 bytes. So like this simple calculation, you can certainly go ahead. So remember one very important thing in one-dimensional array, in one-dimensional array, so list of items, normally they are successive. They are successive and uh, successive in the sense first element 1, 2, 3, 4, 5, 6. So what happens if you want to access particular element, you can certainly write x of I, where I can be variable which can vary the value from 0, 1, 2, 3, 4 up to n. So it can vary, and like this you can certainly use it. Anyhow, we'll see that in the program. And now, how to create and initialize an array. So look at this first example, initializing an array. Initializing an array means you are creating as well as you are giving values to an array. So whenever you say uh, 5 numbers of 5, so what happens? Numbers of 5. So a 5 size array of size 5 is created with first element 3, second element 7, third element 12, fourth element 24, and fifth element 45. So it is stored. Even if you don't give like this, automatically what is the total number of elements that you have, so much you can get it. So much you can get it. And same way, if you have given numbers of 5 and you have given only 2 elements, what about rest? Rest are filled with 0. And if you are just given 1,000 elements and you have specified only 0, so what happens? First element gets 0 and subsequently all the elements get 0. So this is also you can get it. So this is how you can initialize the arrays. You can initialize the array. Very, very important. And this will be definitely helpful when you are working with placement papers. So this is very important. Here comes the first demo program. In this demo program, what happens? You are creating an array called ARR, and you are using a iterating variable I. So I value varies from 0 to 10. So every time what you are doing, you are storing AR of I, that is 0, a array of 0, you are storing the first element, that is I plus 1 into 12. So 12 is stored. When I increments, I becomes 1 here, and 1 plus 1, 2, 2 into 12, that is 24. So 12, 24, 36, 48, so 60, 72, like this. 12 table, that is starting from 12 to the last element, it is stored. So the same thing you can see in this particular example. And finally, what you are doing, once you store them, you can also display them by using the same for loop. For loop you put for I is equal to 0, I less than 10. In fact, it is 10. I is less than 10 and I plus plus. So every time you display the value, what is there? First, tells the index number. Second, AR of I indicates the value. So when you run this code, in fact, I just put the uh, just put the same thing in the chat box so that you can also work with me simultaneously. Okay, so the same program you can also run with me. So as soon as I execute this code, what happens? It is printing. So ARR of 0 gets 12, 1 gets 24, 3 gets 36, so 9 gets 120. The same thing it is, you are putting in a for loop and you are displaying. This is how exactly the array are created, stored, and it is displayed. And all 10 elements are stored using a variable called array, ARR. ARR. So that is the the thing. And of course, similarly, you have one more program which is given from your textbook, Fibonacci series. Suppose Fibonacci series, I think most of you know, it is a series of numbers. Starts with first number starts with 0, second number starts with 1. The third number or the next number in the series is always the addition of the previous two. So 0 plus 1 is 1. Next, 1 plus 1 is 2. Next number, 2 plus 1 is 3. Next number, 3 plus 2 is 5. Next number, 5 plus 3 is 8. Next number, 8 plus 5 is 13. Next number, 13 plus 8, it is 21. So like this, the series continues. And this particular program will print 20 such numbers. So this kind of series of numbers, you call it as Fibonacci numbers. So what you are trying to do is you're creating an array of Fibonacci of size 20, and I is an iterating variable where it works in for loop. Now, you know the first element in the series, so it is 0. Second element in the series is 1. The first element is 0, second is 1. Now, third element, which has to be since we starts from 0, first element, second element, third element. So it starts from 2. So you're writing 2, and the loop is going up to 20. Every time your Fibonacci of I is nothing but it is the addition of the previous to previous and previous. So addition of these two numbers, previous number and previous to previous number, you are adding and you are storing. And this particular loop will continue for up to 20 numbers. Yes, once it is done. So you can display the Fibonacci of first number is what? Fibonacci of second number is what? Fibonacci of third number is what? So since it is put in the for loop, you can see all the numbers in the series and you can get it. So same code is available in this particular link. I just click on this link. The same link, I just put it in the chat box also so that you can work simultaneously with me. Yes, you can see as soon as I run this code, you can certainly see. So first number is 0, second number is 1, third number is 1, fourth number is 2, 3, 5, 8, 13, 21, and the 20th number is 4181. So how you got 4181? It is the addition of the previous two numbers, these two numbers. So it is, and so every number is just like that. It's the addition of previous two numbers. So that is how it is working. And this is what you call it as arrays. So one more example on arrays we can certainly get. Now the character arrays. Similarly, you can also have array of characters. Array of integers, you have seen. Array of characters. Array of characters, we call it as strings. But one unique characteristic of a string is the last character of the string will hold a null character. That is backslash 0 is a null character. Or you can certainly capital letter NULL you can write. This is automatically, it is there in the string. Whenever you create a string, automatically. So when you say character name of 11, what happens? So of course the first character starts from 0 and goes up to 10. The 11th character is automatically, it is a null character. The last character will be null character. So you can see where name of 0 through name of 9 will contain all the characters comprising of names, and The last character, that is actually 11th character, will store the null character. Null character is nothing but the last character. So here is one example. So A, B, C, D, F, G, H, the last character is null. You can see null, null character. So it is just like this. So only thing you have to use, instead of integer, you have to write it here as character. So it has to be used as a character. So char string of 11. So 11 characters are there. So where 0 to 10 it is characters, and the 11th character you have null character, that is forward slash backslash 0 backslash 0. So this is there, the 11th cell. The 11th cell will have this. And of course, most of the times you don't use subscription for this. You can certainly directly, they can be used. So look at there. If it is character, means it is taking only one byte. Each character will take only 1 byte of memory space. So what happens if the base address is 100? So it can go up to 110. All 10 digits it will store, and the last character will be containing null. So based on this, we have one example. Look at here. We are trying to read a number, a name. We are trying to read a name, and so it is a getters, f getters name. You are getting it from the standard input. That is, you are taking from standard input, and you are displaying hello name. You are just displaying. So the same program, it is there in uh, this particular website. You can see the program is already typed. So in this program, you are reading a string and you are displaying. So I have already given the name of the string. Of course, the URL I'll paste it in the chat box so that you can simultaneously run along with me. Okay, so this is the URL for this particular program. In this program, you are reading a name and displaying. So when you run this, what happens? It is going to read the name, and name I have already given Satish. Satish is the name that I have given, and it is displaying hello Satish. It is giving like this. Hello Satish, it is giving. So, but exactly how exactly it is storing, you are not able to visualize. So for this, I have a visualize program. So I'll give the this program also. You can see the link also. I'll just give it. So his program is generating. Yes. Now look at here. I have stored name of. Suppose if I edit name of 30 is equal to Dr. Rama space Satish space K space V. If I give like this, so what happens? It will store, and the same thing you will display. And now visualize the code. When I say this, what happens? All the characters, D stores in first cell, and of course you can see initially only name is there. When I give this, when I execute, this is the line that it is executing. When I execute this, what happens? The dr dot space Rama space Satish space K space V. Rest all characters are null. You can see up to 29th character, it is null. So unnecessarily it is wasted. Unnecessarily it is wasted. So this is one thing that you should understand. Unnecessarily it is wasted. So and when I say print, what happens? It is going to print the name. Hello, Dr. Rama Satish. It is going to print. So what I do, instead of writing 30, I just give, instead of giving 30, I just give only open bracket and close bracket. Now you observe, visualize. I just give the visualize. what is exactly happening in memory. So it is creating an array, and when I initialize the array, what happens? Only the characters, how much characters it has, only so much memory is allocated, and last character is automatically taken as null. So it's an array with character, and you can certainly display. Yes, hello, Dr. Rama Satish. That is the thing. So this is how it is going to work, and you can also certainly type this program and check it out. So I generate one permanent link. I think I just copy this link and put it in the chat box so that you can also run this program. It's a very big link. You can just click on it. It will come to the same thing. You can edit the code. You can do the visualization. You can check how exactly the memory is being displayed according to this program. So that is a thing that you should understand. Now, moving further, two-dimensional array. How exactly two-dimensional array are created? So whenever you want to create a two-dimensional array, first you have to give the type of the data element and the name of the array, and give the row, how many rows you want, how many columns you want. So they are all put in square brackets. Once you give, so much table is created. So much data table is created. Suppose if we create 3 cross 3, an array with the 3 cross 3, what happens? So it is created. You can see it is created. So 3 rows, 3 columns are created. Now, in fact, memory is a continuous memory, but how exactly memory is stored? So what it will do, it will say row 0, column 0, first cell, it is given, first cell, row 1, column 1, yes, it is put here, row 1, column 2, yes, it is put. Row 1, column 0, row 1, column 0, you can see row 1, column 0, row 1, column 1, row 1, column 1, row 1, column 2, yes, it is put like this, and row 2, column 2, column 0, row 2, column 1, row 2, column 2. So it is stored like this. So minus, plus, and slashes. Okay. So it is stored. This is called row major order. Row major order of creation of two-dimensional array. Even though you represent the array as 2 dimension, they're actually stored like a series of memory address. But you should understand how exactly they are going to be stored. And of course, I'm sorry. Of course, yeah. Of course, when I run this, there are another method, column major. So when I say column major, so what happens? Some column major. So what it will do? It is a row 0, column 0, row 0, column 0, row 1, column 0, row 2, column 0. So it stores like this. So it stores like this. So all these things are stored like this, and next all these things it is stored like this. So column 1, row 0, column 1, row 1, column 2, row 2. So column 2, row 0, column 2, row 1, column 2, row 2. So it is stored like this. You can see. So this is stored like this. So that is the uh, thing that you should understand. So even though two-dimensional arrays are visually they are two-dimensional, but actually they are stored like this. Okay, let us go to visualize program, and I just clear the screen. Let us see how exactly what happens. So if I try to create an array of 3 cross 3 or 3 cross 5. So what happens? Let us understand, visualize. Okay, I just leave it. Yes, visualize. So whenever we create 3 cross 3, observe here. So the array, 3 rows are created and 5 columns. 1, 2, 3, 4, 5 columns are created. 3 rows and 5 columns. This is how in the memory the allocation is going to happen. Is going to happen in this way. So I have given here the character array. Same array, same way I can also give an integer array also. So this is how. And you can also create the type, the array name, and the subscription. So this is multidimensional array. Multidimensional array will have so many, 3 or more subscriptions. So here 3 subscriptions are there. Here 1, 2, 3, 4 subscriptions are there. So it is the same. It's the same. So they are how multidimensional arrays are created. And of course, you can see here is one example. In this example, what I'm doing, I'm having 2 matrices, A and B. So A matrix is having 5, 6, 7 as first row, and 10, 20, 30 in the second row. And of course, same thing, 1, 2, 3 in the first row of B matrix, and 3, 2, 1 in the second row. So what happens when I calculate the sum of, so here first I'll create a for loop for row handling. The same way another for loop I'll create it for column handling. So 2 rows, 2 for loops I had to create it for handling rows and columns. And sum of row and column, I can certainly write it as A of row column plus B of row column. So it will go on to add these two and put it in result. Put it in result, that is sum row. So put it in sum, and finally it is going to be printed. In the next slide, what we are trying to do is we are going to print. So when we print the sum of matrices, so you are trying to, in the previous for loop, you have created calculated the sum. Now what you are doing, you are trying to print the sum of rows. So you are printing it, and of course, the same program is available here. You can see, so you can certainly see the program. So I have initialized the array. So there are 2 matrices, 2-dimensional matrices. I'm trying to add them and trying to print them. So when I run this, I can certainly get, so 5 plus 1 is 6, 6 plus 2 is 8, and you can see 7 plus 3, 10. So 6, 8, 10. Same way 13, 22, and 31. So sum of these 2 matrices, you can get it. And of course, same thing, I just copy the link so that you can also execute along with me. And same program, I just copy it. Same program, I just copy it, and I give it to visualization. So I just give it to visualization. When I give it to visualization, so what happens? You can see as soon as I give it to visualization, so the visual codes are created. And first it will create matrix A and matrix B. You can see matrix A and matrix B and sum. Initially they are all blank. Initially they are all blank, and row and column also blank. So as soon as I run this code, what happens? A gets values. You can see A 5, 6, 7, B 5, 6, 7, and 10, 20, 30. Same way B 1, 2, 3, and 3, 2, 1. And after calculating the sum, so what is that it is doing? It is calculating the first row, second row, next third row, next second row, first column, second row, second column, second row, third column, and after that you are printing it. So you are printing it. You can see you are printing it here in this output box. You are printing it, and it is just displaying 13, 22, and 31. See, this is one way how exactly the operations are being done. So this is the memory visualization. This is how you get the output. So this is one of the fantastic program. I generate the link. So I just copy the link and I paste in your chat box so that you can also try. You can also try this program so that you can analyze one step by step what happens, what is happening. You can easily understand. See, you can say next, 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 and finally it returns 0. So you can easily understand how exactly things are going to be done. So that's about today's class, and hope I have given one small examples introduction to all these concepts. These concepts you have already learned in your CCP, but still in the module 1, these topics are again, it is repeated. So I'm just taking it. So entire C, whatever you have learned in first sem or second sem, we have to finish it within 8 hours. So that's the reason we are doing it. And in the next class, we are going to talk about one of the very important topic, that is structures and unions. If time permits, I'll also touch pointers. Very, very important. So that's all for today's class. Thank you. So all the class recordings, videos, notes, everything is available in this particular website. So please do it and do visit it. And another thing is in the Google Classroom, I have already given one assignment for everybody. Probably check your emails. Yeah. Please submit your assignment. Pawaman has already submitted. He's saying very good. So I want everybody to solve that assignment and submit it in the Google Classroom, so that the assignment marks, I'll give it there itself, and it will be notified to you once it is done. So the time will be given to solve this assignment is up to Monday. So Monday, I will release the scores. So before that, you can submit the assignment. You can write the code, can copy the code in one PDF file, and you can submit it. So thank you. Have a wonderful day. 1 minute, less than 1 minute time left. Anybody wants to ask anything, you can ask. And meanwhile, you can talk to me over phone or WhatsApp. So thank you. Stay safe. Have a nice weekend. Please type in your USN in the chat box. I want all 49, 50 students were there.